Hi guys, this is Siri, and today we're going to be talking about typecasting and the concept of immutability in Python. So first, let's talk about typecasting. Typecasting is used to convert one data type to another data type, and the following functions are available. So there's int, there's float, complex, bool, and there's str. And if you need a refresher on these data types, feel free to check out my other videos on these data types. But for now, let's talk about casting to the int data type. Okay. So we can convert from any data type to the int data type except for the complex data type. And if we want to convert a string to an int, the string should only contain integral values and should be specified in base 10. So let me give you an example. So if you wanted to print like 10, which is a string because it's in between quotes, and you want to convert that to an int, and we print the type of that, we're gonna get an int. Okay. But if you wanted to print a string and convert that to an int, but that string wasn't an integral value, like say it was like, I don't know, a blueberry, okay, you get a value error, so you can't really do that. And you can convert booleans to ints as well. So if you convert true to an int, you get 1. And let me remind you that true and false are the two states of logic in Python. So there's true and there's false, and internally Python stores true as 1 and false as 0. So that's why you get 1 when you convert true to an int. Alright, and similarly, if you wanted to convert false to an int, you're going to expect to get 0. Right, you get 0. Alrighty, and also, when you, going back to strings here, converting strings to ints. So if you print int and you wanted to do like 9.7 as a string, that's not going to work. Like, you need like an integer value, and this is a float, right? So you can't do that either. And if you wanted to do something funky, like print int, convert 10, like the word 10, T-E-N, into an int, that's not going to work either, right? Because that's not really an integer. And so we can't convert the complex data type to an int. Can't convert complex into int. So if you tried that, like if you said 10 plus 5j, you're gonna get a type error. You can't convert complex to int. Alright, so that's that. I think we should move on to casting to float. So it's pretty similar to converting other data types to an int. You can't convert complex into a float, and if you tried here, you do float, and then let's do the same 10 plus 5j. You also get a type error. You can't convert complex to float. Okay, and so let's try the other data type. So if we wanted to print true as a float, you get 1.0, and the reason you don't get 1 when just like when you converted true to an int is because floats have decimal points, and the point 0 is not there for an int, but it's there for a float. Okay, and if you wanted to do print float false, you get 0.0. Print float. Okay, you see here when you try to do print 9.7 as an int, when you tried to convert the string 9.7 into an int, you got an error. But here, since we're converting it to a float, you can do 9.7, 9.6. You get 9.6. Okay. And we can also print integral values as well. So if we wanted to do 20, we would get 20.0. So I think that's about it for converting other data types to float data type. So now let's talk about converting to the complex data type. Let's talk about the complex function. Okay, so there are two forms when converting other data types to the complex data type. And so first let's talk about form 1. There are two different ways you can do it. So the first way is to have the function complex and have it take an argument of x, alright? And so let's do this here. So print complex, let's put 10 in there. You get 10 plus 0j. Print complex. You put 10.5 in there. You get 10.5 plus 0j. You print complex, the function complex, and you pass in true. 1 plus 0j. When you pass in false, 0j. And you pass in string 10. Okay, 10 plus 0j. Print complex and taking the argument of 10.57. 10.57 plus 0j. So you're starting to notice a pattern here, and we can use this function, this form, to convert x into a complex number with the real part x and imaginary part 0. Alright, so that's form 1. That's the first form. There's another way you can do it. Okay? The second way is to have the function complex, but instead of x as the argument, you have x and y. Okay? And let's do another example here. Let's do complex, and let's let 10 be x and negative 2 as y. Okay? So then you get 10 minus 2j. Okay? 10 was x, negative 2 was y. You get 10 minus 2j. So now let's pass in true, and let's pass in false. Remember that true is stored as 1, and false is stored as 0. You get, oh, let's print both of them actually. You would get 1 plus 0j. Okay? So there's another pattern here where all the, so whenever you pass in the x, that's going to be the real part. So the real part is x, and the imaginary part would be y. Okay, so these are the two ways you can convert another data type to a complex number. Okay, so I think that's enough. So now let's talk about casting to booleans. Okay. Okay, so here, any value that is pretty similar to 0, you're gonna get false, and anything that has a value is going to be true. Okay, so you have here print bool, and let's pass in 0. So we're going to convert the integer 0 to a boolean, and we get false, right? So I said here. But it doesn't always have to be 0. It can be something that's kind of similar, like an empty string, right? So print bool, and you have an empty string, right? You get false as well. Okay, so now anything that has a value, however, is true. So bool, and then you pass in 1. Well, 1 is stored as true in Python, so it's no surprise that you get true. But if you have print bool, like a tree, okay, you're gonna get true. If you print bool 10.5, you're gonna get true. You can put anything in there, honestly. You can do 0 plus 1.5j, get true. Print bool, and then if you wanted to put false in there, you're not gonna get false because, first of all, this is a string and it has some value within that string, so you're gonna get true. So yeah, anything that has a value is true, and anything that's pretty much a 0 is gonna give you false. So now let's talk about casting to strings. Casting to a string. Okay, so whatever you pass into this function, it's just basically gonna give you the same thing except with quotes around it. So if you wanted to print str and put 10 in there, it's going to give you, well, if you take out the print, you're going to see that this is Jupyter Notebook, so you don't need to put print on the last line of the cell. So you get an output of 10, and you see that it has quotes around it. If you wanted to do str and then 10 plus 5j, you also get quotes around the complex number. If you wanted to do str true. It's going to give you true with quotations around it, okay? And if we want to see the type of this, you're going to get a string, okay? So I think that's about it for typecasting. So now let's move on to the concept of immutability, and this is pretty important in Python. Okay, so in Python, all fundamental data types, meaning these 5 data types, there are more data types, but these 5 data types are immutable. Okay, what does immutable mean? It means not mutable. Mutable means changeable, so not changeable. Okay, so all fundamental data types are immutable. Okay, so once we create an object, okay, we cannot perform any changes to it. Okay, so if we have a string, okay, A equals I don't know, mango. Okay, and if we want to change the G, okay, and we want to say like, so G has the index value of, so this is 0, 1, 2, and then 3. Okay, so 3. And instead of a G, I want it to be a W. Okay, you're going to get an error. The string object does not support item assignment. Okay, so you can't change it. Okay, I've seen some people have a doubt because when they say, hey, A equals, or let's say B equals watermelon, and so B equals watermelon, right? And when you print B, you get watermelon. But here we're saying, oh, B equals like laptop. Okay. So now when you print B, it's laptop. Okay. So what does this mean? Does this still support the idea of immutability? It does, because this is not changing the object watermelon. So let's draw a little something for you here. So the variable B, okay, in the first line here, B equals watermelon, we're saying the variable B has a connection to, has a link to the object watermelon. Okay. In the second line, we're saying, hey, B has a link to the object laptop. So we're breaking this bond here, and we're saying, hey, let B correspond to the object laptop. We're not changing the watermelon object. We're just saying, hey, the variable B is going to point to laptop. So that's why when you print B, you get laptop. You don't get watermelon, because B doesn't point to watermelon anymore. It points to laptop. Okay, so that's what's going on right here. So yeah, that's that. And I can prove it to you. I can say, hey, x equals 10. Okay, I want y to equal 10. We're gonna find the ID, the memory location of x. Okay, it's 44449763832, something like that. And then we're going to print the ID of y. It's the same. What does this prove? This is showing that you have the variable x. It's pointing to the object 10. And then y comes along. It doesn't create another object 10. No, it doesn't do that. Erase the whole thing. Okay, so there's x and then there's 10. So what it does here is that y also points to 10. So this proves that in Python, this is another concept, this proves that in Python, if a new object is required, right, like 10 and 10, Python won't create it immediately, okay? It's going to check if there are any existing objects and try to reuse it, okay? And this is actually really useful, and let me give you an example in how it's useful. Okay, so for example, like what if you had like a registration, okay, and in that registration form you needed to like say, hey, where are you from? And like a lot of people said they were from Boston, Massachusetts. Okay. Now, if Python created a variable for every Boston, Massachusetts that the person lived in, it doesn't utilize the memory as well as it should, right? Because it would be a waste if you had like so many like Boston, Massachusetts, when you could have just had all those people point to the same object, Boston, Massachusetts. So that's how it's useful. So the advantage of this approach is memory utilization, and the performance will be improved. So that's why it's useful, and this ID x and ID y, this proves this concept. Okay? So it's the same, it points to the same object. Alright, so I think that's it for this video. We talked about typecasting, and we talked about the concept of immutability in Python and how all of the fundamental data types are immutable. And I hope you learned something new today, and I'll see you in the next video.